Hello everyone, first of all thanks for being here in my YouTube channel. Let's solve some problems based on three-phase AC circuits. Before solving the problems, we'll revise once again formulas, okay? So the relationship between star connected load is VL is equal to root 3 V phase, right? Current is equal to IL is equal to I phase. So Z phase if you want to calculate V phase by I phase according to Ohm's law. So finally power is equal to root 3 VL cos phi, right? So voltage drop across R and Y, that is VR minus Vy. So voltage between R to Y line, and then similarly VYB, and then similarly VBR. Okay. Next there's a delta connected load. So in delta, IL is equal to root 3 I phase, VL is equal to V phase. Voltage will be same and the current will be different. And then similarly IR is equal to IRY minus IBR. Already we discussed in the theory. Next there's a power is equal to root 3 VL cos phi for the same as a star. Okay. Next there is a wattmeter. Wattmeter is equal to what? Power is equal to VI cos phi, right? For single phase. So this is V and then this is I. Cosine of angle between this voltage and this current. Okay. Next there is a 2 wattmeter method. Total wattmeter reading is equal to W1 plus W2, right? And then total wattmeter reading, if you add those two, you get root 3 VLI cos phi. So W1 is equal to VLI cos 30 minus phi. W2 is equal to VLI cos 30 plus phi. We got this one from the vector diagram of 2 wattmeter method. Okay. So next is the power factor. Power factor, if you want to calculate, cos phi is equal to cos of tan inverse root 3 W1 minus W2 divided by W1 plus W2. We will solve some problems based on three-phase AC circuits. The first problem is a balanced three-phase delta connected load has per phase impedance of 25 plus J40 ohm. I'll be drawing diagram now. Delta connected load, right? This is delta. So Z phase is given 25 plus J40 ohm, right? So this Z phase is equal for this phase and this phase, okay? And supply voltage is given how much? 400 volts. Three phase 50 hertz, okay, supply is given. So find current. We need to find current, that is I phase we need to calculate, and a line current we need to calculate, and power supplied by the load, power we need to calculate. So what is the condition for delta relationship between voltage and current? So IL is equal to root 3 I phase, right? So VL is equal to what? V phase. So directly they have given, so 400, right? 400 volts. So now we need to calculate I phase. I phase is equal to V phase by Z phase. So how to calculate Z phase? Z phase is equal to root of R square plus XL square. So that is root of R square is how much? 25, right? 25 R. So 25 square plus this 40 square. 40 square, you will get 47.17 ohm. Just use calculator, okay? Next, we need to calculate I phase. So I phase is equal to V phase by Z phase. So V phase how much? 400 divided by 47.17. We will get 8.48. IL is equal to root 3 I phase. How much you will get? Root 3 into 8.48. So we'll get IL is equal to 14.7. Okay, 14.7. Next, power is equal to what? Power is equal to root 3 VL IL cos phi, right? So we need to calculate cos phi now. Cos phi is equal to what formula? Cos phi is equal to R by Z. So R is 25 divided by, what is the value of Z? So Z phase is 47.17. Finally, you will get 0.5. Just to substitute over here, root 3 VL is equal to V phase 400. IL is equal to what? This 14.7, and cos phi is equal to 0.5. Finally, you will get answer as 5397 watts. Once again, we will cross check the answer. Z phase is equal to what? Root of R square plus XL square. This one is Z phase, and then phi if you want to calculate tan inverse of XL by R, that is 60 degree, and Z phase is equal to what? This value, okay, 47.17. VL is equal to V phase, I phase is equal to V phase with Z phase, and IL is equal to root 3 I phase, power is equal to root 3 VL cos phi. Finally, we got 5397 watts. Next problem, calculate the active and reactive components of each phase of a star connected 10 kV 3-phase alternator supplying 5 megawatts of 0.8 power factor. Definitely it's an alternator, it's a generator. So there is a star connected load. What is the condition for a star? I mean, relationship between voltage and current. VL is equal to root 3 V phase and IL is equal to I phase, right? Conditions. So power is given, active power is given. So 5 megawatt, and then VL is given, that is 10 kilovolts. and there is a three-phase. Power factor is given, cos phi is equal to 0.8. What we need to calculate? First, active power we want to calculate per phase. Okay, per phase, this is active power actually. Active power per phase, 5 into 10 raised to 6 divided by 3, we will get 7 megawatts. Right. Next, there is a uh, reactive components of each phase. Definitely, Q is equal to what? Per phase, V phase, I phase, sin phi is a formula. For reactive power, Q is equal to V phase, I phase, sin phi. If it is three phase, we have to take 3 V phase, I phase, sin phi, but they mentioned each phase, right? So that's why I have taken Q is equal to V phase, I phase, sin phi. So V phase is what? V phase is equal to VL by root 3, right? So VL by root 3 is how much? VL is given 10 kilovolts. 10 kilo divided by root 3, 5773.5 volts. So next, what we need to calculate? IL we need to calculate, right? IL is equal to I phase. IL I'll calculate. So power is equal to root 3 VL IL cos phi, right? So root 3 VL is how much? 10 kilo into IL is we don't know. IL we need to calculate. Cos phi is what? 0.8. Power is given 5 megawatts, right? This is a formula. So finally IL is equal to 5 into 10 raised to 6 divided by mega is 10 to 6. Root 3 into 10k into 0.8. Finally, we got 360.84 amps. Okay. Next, we can calculate Q. Q is equal to V phase how much? 5773.5 volts into I phase is what? 360.84 sin phi. Sin phi we don't know, right? Phi we need to calculate. Cos phi is given. Phi is equal to cos inverse of 0.8, you'll get 36.86. So you substitute over here 36.86, you will get 1.25 MVAR. Next problem, a three-phase load of 3 equal impedances connected in delta across balanced 400 volt supply takes a line current of 10 amps at a power factor of 0.7 lag. So it's a delta connected load, right? So 3 equal impedance in the sense are balanced. Okay. So the voltage is given. Supply voltage is 400 volts. 10 amps is the line current is given, and power factor is 0.7. What we need to calculate now? So we need to calculate phase current. I phase we need to calculate, and then total power, that is power is equal to root 3 VL IL cos phi. Okay, and total reactive kVAR. So Q is equal to root 3 VL IL sin phi. We need to calculate, right? So the delta conditions relation between voltage and current is IL is equal to root 3 I phase, right? And VL is equal to V phase, right? So first I'll calculate I phase now. I phase is equal to what? IL by root 3, that is 10 by root 3, 5.8 amps, right? Next, VL is equal to V phase. VL is equal to V phase is equal to 400 volts, right? So cos phi is given 0.7. Directly you can calculate, right, this one. So root 3 VL is 400 into IL is IL how much? 10 amps into cos phi is 0.7. Finally, you will get the answer as 4.84 kilowatts. Next, we need to calculate a reactive power, that is Q is equal to root 3 VL IL sin phi. So root 3 into VL is 400, IL is 10 amps, and sin phi we don't know, right? So how to calculate phi? Cos phi is given, and phi is equal to cos inverse of 0.7. So you'll get 45 degree. So you'll substitute over here root 3 into 400 into 10 into sine of 45 degree. You will get answer as Q is equal to 4.9 kVAR. This is the answer. Okay. Once again, I will cross check the answer. VL is equal to V phase 400, IL is equal to 10 amps, power factor is equal to cos phi 0.7, phi is equal to cos inverse of 0.7, 45.57, I phase is equal to IL by root 3, and power is equal to root 3 VL IL cos phi, and Q is equal to root 3 VL IL sin phi. Next problem, the power flowing in a three-phase, three-wire balanced load system is measured by 2-wattmeter method. The reading in wattmeter A, I'll take W1 is 750 watts, okay, and wattmeter B is I'll take W2 1500 watts. What is the power factor of the system? What is the formula for power factor? Power factor is equal to cos of tan inverse root 3 into W1 minus W2 divided by W1 plus W2, right? So I'll just substitute the values. So cos of tan inverse root 3 into W1 is 750 minus 1500 divided by 750 plus 1500. Okay, you calculate this part first. After the tan inverse of that answer, cos of that answer, you'll get power factor is 0.86. Okay. So we'll cross check once again. W1 is 750, W2 is 1500, 5 is 5 is 30 degree we got. So cos of that 30 degree is 0.866. Right.